Welcome student to the second derivative test. So far we have seen the first derivative test where we do the number line and we find where the function is increasing or decreasing, and then we say if it's increasing and then decreasing we have local maximum. If it is decreasing and then increasing we have a local minimum. This was called the first derivative test. Today we will have a shorter test, and this test will be very helpful when we do applications because it will tell me if you have a critical number, which means the derivative is equal to 0 at c. To find if it is maximum or minimum, you only need to look at the sign of the second derivative. If the sign is negative, then f has a local maximum at c. If the sign of the second derivative is positive, then f has a local minimum at c. Now, sometimes we might get that the second derivative is exactly 0, so our second derivative test is conclusive. So in this case, we will return back to use the first derivative test. So keep in mind, we will go to the second derivative and we will substitute the number c and we check if it's positive or negative. We can tell if it's maximum or minimum. This is very helpful when we do application because I just need to make sure whatever I get is maximum or minimum. So let's do example number 1. It says that use the second derivative test to find the local maximum and local minimum, of course, if they are actually. So the first step, as we did before, we need to find the critical numbers. So we need to find the critical numbers. And in this case, we will only find where the derivative f prime of x is equal to 0. Why? Because for the second derivative test, we only focus on the case where the derivative is equal to 0. What is the derivative of this function? It is just 3x squared negative 12 equal to 0. So we will get either x equal to 2 if we do mod 5 3, or it is negative 2. Now, is this gonna give me maximum? I don't know. If this is gonna give me maximum, I don't know. Minimum, I don't know. So what we will do, we will find the second derivative. So let's go ahead and find the second derivative. So just let me write down what we need to do. We will apply the second derivative test. What is the second derivative test? It means we need to find the second derivative, and the second derivative is just 6x. Okay, so what we will do, we will substitute 2 in the second derivative and we will check the sign of this. Okay. So just let me remind you, we have the second derivative is equal just 6x. Now, first, we will substitute in the second derivative, we will substitute 2. If we do that, the answer will be 12, and we know that 12 is greater than 0. If it is the second derivative is positive, hence f has a local minimum at x equal to 2, which means x equal to 2 is a minimizer. So we have the minimizer is equal to 2, and the value of the local minimum is y equal f of 2. So we go to the original function and we substitute 2 instead of f. So if we put 2 here and 2 here, we will get f of 2 equal to 17. And this is the minimum value. Remember the word minimum with the M, it means we are dealing with the y value. Minimizer is the x value. We focus on the value of the function, which is 17. Next, we go ahead and we do the same thing we just did, but this time for -2. So we substitute -2, we get -12. This is less than 0. Hence, f has a local maximum at x equal -2, which means x is maximizer, and the value of the local maximum is y equal f of -2, which will be so substitute -2, this is -8 plus 24 plus 1, that would be 17, sorry, so this is 17 here. I think I did a mistake here. This would be just 8 minus 15. Okay, so this is the local maximum. So we can see that there is an easy and fast way to find if it's maximum or minimum just by using the second derivative. So just let me recap what we did. First, we need to find the critical numbers only at when the derivative is equal to 0. We found that x equal 2, x equal -2. Next step, we apply the second derivative test. So we find the second derivative and it becomes 6x. And then we substitute 2 and we substitute -2. If the answer is positive, we have minimum. If the answer is negative, we have maximum, and all what we need to do, we substitute in the function itself. Let's see the next question. Again, we will need to find local maximum and minimum, if any. So the first step, we find the critical numbers. And in order to find the critical numbers, I will find the derivative and I will make the derivative equal to 0. What's the derivative for this function? It will be -8x cubed, and that means x is equal to 0. So I have only one point that could be a candidate. Next step, we will apply the second derivative test. So in order to apply the second derivative test, you need to tell me what is the second derivative, and the second derivative will be just 24x squared. Next step, I will substitute my critical number, which is 0. I will get 0. Remember, if we get 0, which is not positive, not negative, we will stop. If I go to the formula again here, if this derivative again is 0, the second derivative, we say that the second derivative test is inconclusive. And what we need to do, we need to go back to the first derivative test. So here we will stop and we will write the test, the second derivative test is inconclusive. It means it doesn't tell me any information. It could be positive, it could be negative. So we need to apply the first derivative test. Now, what is the first derivative test? All what you need to do, so here, apply the first derivative test. we get. We need to do the number line. Here we write the critical number, which is only 0. And you have to tell me what is the sign of f prime of x. What is f prime of x? It was negative 8x cubed. How do I know if it is positive or negative? Take a test value here. Which one will be the test value? I will take 1, simple. Substitute 1 here and 1 here, the answer will be negative. So all this area will just go to be negative. Now, next, substitute negative 1 here. This area will be just positive. So the function is increasing here. The function is decreasing here. Hence, f has a local maximum. Why maximum? Because the function goes up and then down. So I reach the top at x equal to 1. So 1 is a maximizer. You see, in this case, I only found it using the first derivative test, which will always find for us, but sometimes the second can give us easier way rather than do the number line. And the maximum value is y equal f of 1. If you just remember what is f of 1, this is f of 1. If we substitute 1, the maximum value will be just 5. And that's how we did this question. Last question here in this topic. We are giving that the critical number is x equal 1 and x equal 2. We are giving the second derivative, and it says where does f has local maximum or minimum. This question is even easier than what we did before, because here I have the second derivative. I don't need to find the critical number and then find the second derivative. Everything is given to me. All what we need to do is we only need to substitute the value for x. So that will be, first I substitute x equal to 1. So directly I'll just write f double prime of 1. How much we get? We substitute 1, we substitute 1. That means 4. Now 4 is positive, hence f has a local minimum. Why minimum? Because the derivative is positive at x equal to 1. We cannot find the minimum value because I don't have f of x yet. Now, for the other critical numbers, we just need to substitute it again. So x equal to 2, we substitute 2. Now, if you substitute 2 here, this will be 12, this will be 32, and this will be just 17. If we add them, this will be just minus 3. Again, if it is a minus, it is less than 0, hence f has a local maximum at x equal to 2. And that's how we solve this question. So this question kind of similar to the previous one, but the easier part here is that I have the critical numbers and I have the second derivative. So it's direct substitution, and I just check if it's positive or negative. What we will do next, we will do application where we will again use